This experiment shows how by adding static electricity to a bottle of rice, the bottle will not fall.
By shaking the bottle filled with rice, the rice inside rubs against each other and becomes negatively charged with extra electrons, which creates static electricity.
When the chopstick is put into the regular bottle, it falls out as expected, but when it is put into the charged bottle, the bottle raises with the static clings to the chopstick.
The Mentos and Coke experiment is a good example of Boyle's law because when the Mentos are added to the Coke, the liquids start to expand.
Boyle's law says that pressure changes when volume changes.
When the liquid in the Coke container expanded, the pressure became so great that the Coke shot out.
The salt and pepper were mixed to the point that they were unable to get apart.
We rubbed a plastic spoon on a piece of cloth to give the spoon a negative charge by adding electrons.
The pepper was picked up by the spoon because it was positively charged and attracted to the negative charge on the spoon.
The reason the can was able to go back to its normal shape was due to Pascal's principle. When the carbonated liquid inside the can was shaken up, the liquid began to expand and the pressure increased.
The pressure reached its full capacity on the inside of the can and was greater than the outside pressure. This is what caused the can to recover its shape.
The tray with the water, sand, and rocks acted like an ocean. The air from the fan created the waves.
The waves of water reflected off of each material in a different way. The waves reflected off of the piece of wood and bounced back across the normal at the same angle that they came in at.
The hex nuts are able to balance on the edge of the glass because they are attracted to the pull of the magnet.
We could only use 2 of the hex nuts because the magnetic field around the magnets only reached the length of 2.
The Doppler effect is the change in frequency or wavelength of a wave for an observer moving relative to its source.
When the tennis ball was with a buzzer going off inside of it, we swung it around and it sounded like the buzzer's tone was changing, when in reality it was constant.
When the buzzer was going off but not moving, the tone was clearly constant.
When the multimeter was connected to the voltage supply and the current and the voltage was turned up, the multimeter read 20 milliamps.
When the multimeter was connected to the Play-Doh, the multimeter read 0 milliamps.
The Play-Doh acted as a resistor where no current could pass through.